So welcome back to our Puredata tutorial. So in this exercise, we try to perform something relatively new. So in the last couple of exercises or tutorials, we come across the way to make sense of the information in front of our webcam. So in a lot of cases, we just, in the very beginnings, we use the webcam image as part of the content. And in subsequent exercise, we'll make use of the movement in front of the webcam as an control information to determine, for example, the direction of movement and also the magnitudes of the movement of the user. And in the following exercises, we are going to make more sense out of the contents of the webcam image. So the way we would like to interpret the information is by looking into the color information of some of those pixels you would like to detect. So in this case, we'll make use of the pixels RGB information and to perform some of the tracking according to, for example, change in the color and maybe some movement of the colors in order to enable a more advanced form of interactivities. So before that, we'll just recap on what we have done by using the pixel video texture and a rectangle to fill up the whole screen we defined by 800 and 600 pixels. So in this relatively simple patch, we just make use of the video information that's from the webcam and put it as a texture to cover the whole rectangle over here. In order to make sense out of the videos, we have another new commands or new objects. So the object is with a name called Puredata, and if we take a look at the help information, it's kind of straightforward in the sense that all you need to do is to send in the video or other graphical information through the gem list over here. So you also need to notice that the gem list information, that's the graphic information, we are going to send in the second inlet instead of the first one. So the first one will be a band signal. And for the rest of the inlets will be the X and Y position. And in the help message, it also indicate the range of those numbers. And the number will be in the range between 0 and 1. And the orientation is the left bottom, that is around here, will be 0 and 0, and the right top, that is around here, will be 1 and 1. So you need to, for example, pay attention to this one when we are going to convert between different coordinate system. And for the outlet, so what we would like to make sense of will be mainly the second one. So this is the color information. So it tried to send out the RGB information in a packed list. So we need to unpack the color into red, green, and blue components. Or alternatively, you are just looking into grayscale information, you can make use of the last outlet. So we keep the texture and the display aside and try to connect directly the video information into the second inlet. And for the band, we will include a band button and send it through the first inlet. And for the X and Y, you can send in two numbers, and Of course, you can also use, for example, a slider instead. So I put in the range between 0 and 1. And for both of them, one for X and the other for Y. And with this one, you can have a more graphical form in order to locate, for example, in which particular position you are looking into that pixels. And for the outlet, we unpack the list of RGB into 3 single numbers. So this is the use of unpack command. So we unpack a list, and the list will be containing 3 floating point number. So you can see the 3 outlets over here. For each of the outlet, it will be a number. So we have 3 of them, representing the red, green, and blue information. And all those information is also a number between 0 and 1. So those are the initial commands we would like to put in over here. You can have a look of the effect. And the first things you need to do, for example, is to adjust the slider to a position where you would like to collect the pixel information. So in this case, we do not have visual response yet. So in later exercise, we'll make use of, for example, a target or something like a cursor in order to indicate on the screen which position you are picking up the color information. So I put it roughly in the middle for the X and Y, so it's kind of locating information around in the middle of your screen. And the next step is you press on the band. Once you press on the band, you try to collect information of the color. So for each of the band signal, it will change the number over here. So in that case, we may need to think, for example, we can just use a metro over here in order to automate the press command. For example, I'll add in metro objects and use a toggle to turn on and off it. For each of the bits, so I will send out the band signal. To the first inlet of the pix data. So instead of pressing the band by myself, I can use it to do it automatically. So once I turn it on, you can see the change in the color information because of the lighting condition, and we usually do not have a fixed number even though you have no change in front of your camera. So at this point, it is roughly in the middle of your screen. So for example, you can also adjust those sliders towards, for example, for the X1, I move towards the left hand side, and I also move this one, for example, to the bottom, which roughly corresponding to the lower left bottom around here. So if I move it towards the right hand side, so it's corresponding to the bottom on the right hand side. So you can see the difference in terms of the color. The number will be a much smaller. So this is close to 0, which indicate the color is close to black. And if you move it towards the left hand side, the color information will be around 0.5 or 0.6. It's more or less gray around here. So those are the corresponding between the number and also the color information. So instead of reading those numbers by yourself to interpret the color information, I can, for example, add in some visual response on the screen such that you can more or less compare the color between graphical objects and also the live image. So in the patch, I'll consider to add another gem head to produce a very simple graphics on top of the video. So I also add in a color objects because I would like to change the color of that particular objects. So I will put in, for example, a default rectangle. So this will be a square. And what I'm going to do is I'll try to send in the color information because the color object will be expecting a list of RGB. So instead of sending in the 3 individuals numbers, I'll just send in the whole list over here. So I'll do a send with the label color COL over here. And then in the receiving end, I'll put in out with the same label COL. So in that case, I'll try to do is when I pick up color information from the live video, I'll at the same time color this rectangle with the same color such that we can have a match between the color information and the live image. I'll do the test one over here. And I'll put the cursor or the color picker roughly in the middle of the screen for easy alignment. So turn on this particular metal box. So you can see the change in those color which corresponding to roughly the center of the webcam image. So what I'm going to test is I try to use different objects with different color. For example, so you can see the rectangle in the center of the screen change according to those objects. I put it in front of the camera, roughly in the center of the screen. So it's a bigger one, it's quite easier to do the matching. So you can see actually it will pick up the color at that specific pixel and color the rectangle. So you can have something like the rectangle is hiding from the background. Or even using your palm. At this point, it's using just one single piece of pixel, so the detection is only the exact center point, and it won't have anything like averaging and area of the pixel information. So in this exercise, we mainly try to analyze or try to extract the color information. And the subsequent ways we are going to implement the interactivity is we would like to, for example, pick up the color information of a specific point within the camera frames. And then at other points of time, we would like to compare that color pixel information according to the color we have stored. And in case the color changed a lot, so there's an indication that there are some activity performed at that region. So we try to make sense of this component by, for example, dividing your screen into different regions. And if your hand or if your body try to move into a specific regions, so we can make sense of this by evoking or try to trigger some of the audio or other visual response. So this is the other forms of interactivity we try to make use by using the color information tracking.